Hi everyone, today I'll be presenting the method evaluation results from our CBIN project here in Toronto at the Outer Harbour Marina, sharing all the work that was done to investigate how effective CBINs are at capturing and diverting litter from Lake Ontario, and whether our protocols are effective at characterizing and quantifying the litter found in CBINs. So to start off, I'll go over our objectives for this summer. So we first wanted to create two standard protocols. The first protocol being for those who maintain a CBIN on a day-to-day basis, like a marina, to collect the minimal amount of data needed on a daily basis. And the second would be for waste characterization partners, who would be universities or organizations similar to us to follow an intensive data collection protocol 5 to 10 times a season. Next was to determine the accuracy or representativeness of our intensive sampling technique, meaning the step where we subsample to make this protocol as quick and efficient as possible. And lastly was to determine the total weight of a CBIN and whether it can be used to extrapolate both the weight and count of large and small anthropogenic debris diverted from the daily data we collect from marinas or from anyone who uses our daily protocol. So first, going over Objective A, what were the two protocols we developed this summer? So I'll just give everyone a quick overview of what the daily CBIN protocol entails. So you first retrieve your catch bag and shake out any excess water. You then use a luggage scale to record the weight of a catch bag. Now, once you have your weight, you can input it into our Data Trapper app, which is available on both Apple and Android devices. And you input your weight along with all the other general information required from you, and then you'd submit when you're ready. You then empty the contents of your catch bag into the garbage bin, and then place your catch bag back into the barrel of the CBIN. And now I'll quickly go through our intensive protocol and a few extra steps that were taken that aren't in the protocol, but were followed in order to test our methodology. So you first retrieve your catch bag, you weigh the catch bag, and then place all the contents on the table. And you begin to sort through looking for large debris. We define large debris as any piece of litter larger than a toonie. Once all the large debris was sorted through, we would then wash the plant material of all small anthropogenic debris. To do this, we applied what we call the French press technique. And once all the small debris have been poured into the 2mm sieve, if there is more than an estimated 50 to 100 pieces of small debris present on that sieve, you would subsample. This just means you would divide all the contents on the sieve into 4 equal piles and count only one of the piles. And now if there was less than 50 to 100 pieces of small debris on that sieve, you would just count everything present on the sieve. And once we counted the subsample, we then counted the remaining piles on the sieve, so these 3 piles here, in order to test our subsampling methodology. And then to test our washing methodology, we then counted everything present within the plant material after being rinsed 3 times. Both these steps were not included in the protocol, but again, taken in order to test our methodology. So here's a preview of some interesting results that didn't pertain to our objectives, but we wanted to share with you. So first, what is the proportion of small and large debris we are finding in our CBINs? At first, it was unknown how effective CBINs would be at capturing small debris, including microplastics, and thought it would be mostly effective at capturing large debris or macroplastics. And we have found that CBINs are not only effective in capturing macro litter or large debris, but to our surprise, throughout the entire summer, we've seen a consistent trend of small debris being much larger in count compared to large debris, where an average of 84.5% of all debris in the bin is characterized as small. So this leads us to believe that maybe CBINs are more effective in capturing this size fraction than previously believed. Objective B, how accurate and representative is our intensive sampling technique? Before we go into Objective B, I wanted to take a minute for everyone to look at this photo and notice all of the small debris stuck in and trained in this plant material. This sample here resembles the majority of what the contents of the CBINs looked like this summer. And we recognize this both as an issue and an opportunity, which we will discuss later. How representative is our subsampling method for determining the total count of extracted small debris? So here the red column is the actual count, which means it is the count of everything that was present on the 2mm sieve. This includes the subsample and the 3 remaining piles. The blue column is the average extrapolated count of small debris for each dock, meaning it is the subsample multiplied by 4. And here we can see that our extrapolation is accurate thus far from our subsampling methodology. So this would be used by the partners to capture what types of anthropogenic debris we are finding in a bin and an estimated count. And based on the data now, we have each CBIN has an average percent error of 3.4. How much small debris is unaccounted for due to being entrained or caught in the plant material, as we saw in photo? So the next 3 slides will be looking at similar graphs for each dock. Here on the y-axis, we have number of small anthropogenic debris, and the purple bar graphs represent the count on the sieve, which again was everything on the sieve, including the subsample and the 3 remaining piles, compared to the total number of small debris counted in the catch bag, which includes what we counted in the plant material after the 3 rinses, and then again, everything counted on the sieve. And the percentages above each graph depict how much was unaccounted for on average from each category. So we see here that after 3 rinses in the bucket, there is still quite a bit of small debris attached to the plant material. And for each bin, we'll see it's certain categories of litter which are more likely to stay entrained within the organic material. So this is Dock A, the first CBIN. This is Dock B, our second CBIN. As you can see, the categories are staying consistent. And Dock X, the last CBIN. Again, with similar categories being unaccounted for. So in summary, the litter that we lose the most of in the washing process, or the ones that are most unaccounted for, are both film and hard fragments. And we believe that the amount unaccounted for may vary depending on the type of plant material near the CBIN. So we lose about 50% of small debris, which is in the catch bag. And we recognize this as an issue, but when we look at this graph, which is does plant mass drive the amount of small debris collected, we can see that the number of small debris is positively correlated with the weight of the plant material collected by the CBIN. And this was incredibly surprising, as it shows us plant material is a possible mechanism for collecting and accumulating small debris, which is easily visible when walking along the docks at the marina or along the waterfront here in Toronto. This is important because it shows us that although CBINs in Lake Ontario aren't catching much in large anthropogenic debris in weight on a day-to-day basis, which we will look at later, they are capturing and diverting many pieces of small anthropogenic debris. And this is exciting because it shows us that CBINs deployed in Lake Ontario may have more potential in cleaning up and removing small debris, including microplastics, than previously believed. This slide also shows us that it's extremely important to throw away your plant material from your CBIN, as you may not see any obvious pieces of trash, but in each sample that we've ever collected and analyzed, there is always small debris present. And as you can see here in these pie charts, which depict the diversity of small debris found in the bins, that although maybe we don't catch the entire quantity of small debris in our CBIN, we do in fact capture the diversity collected in our CBINs from our subsampling method for both what is found on the sieve and what is unaccounted for in our plant material. So now going over our last objective, Objective C. There are 2 points of this objective. Looking at the first one now, can the total weight of a CBIN be used to extrapolate the weight of anthropogenic debris diverted, both large and small? Here we have a regression plot depicting the total weight of anthropogenic debris, both large and small, found in a sample on the y-axis. And on the x-axis, we have the total weight of the bin. And we can see that it's positively correlated and statistically significant, which means that we can use our daily protocol data from the marinas to provide an estimate of the total weight of debris captured and diverted for a given timescale. The trend is consistent with the total weight of large anthropogenic debris against the weight of the bin. And we believe that given the strong R-squared here, that large debris is driving the overall trend of our previous graph. Because as you can see, the trend for small debris isn't as strong. And this is okay because we'll see in a second that we want to use a different measure to report how much small debris we divert. So now the second part of Objective C, looking at if we can use the total weight of a CBIN to extrapolate the number of anthropogenic debris diverted. So here we have on the y-axis the total count of both small and large anthropogenic debris against the total weight of the bin. And again, we have a strong positive correlation, and we can use the total weight of a sebin provided by the daily protocol data to estimate a total count of anthropogenic debris diverted. We see a similar trend when comparing the total count of large anthropogenic debris. But once we get to look at the total count of small debris compared to the weight of the bin, we see a stronger correlation than with large debris, which can be explained by the role of plant material in accumulating them. And we believe that count is a better measure to report on how much small debris we capture and divert than weight. So in this case, the weaker correlation we saw previously between small debris weight and weight of bin doesn't matter that much. So from the results of our regression plots, it's all good news. We can in fact use our daily protocol data to report both the total weight of anthropogenic debris captured and diverted and report a total count of small debris captured and diverted using the data that we collect from marinas or from anyone that uses our daily protocol data. Okay. So in summary of all of our objectives, starting with objective A, which was to create 2 standard protocols, we have developed what we believe to be an effective and accurate protocol and have made it available to anyone interested in analyzing the contents of their sebin on our website, which is linked at the last slide of this presentation. Sebins collect more small debris than large debris as they become easily entrained in plant material. And the more plant material we have, the more debris we have, both large and small. For objective B, which was to determine how accurate and representative our intensive sampling method is. Based on our results, our subsampling is appropriate for investigating microplastics in a sebin. We have an average of 3.4% error rate, and the diversity of small debris in our subsample is representative of both the actual count on the sieve and the total count of small debris in the whole sample. And lastly, for objective C, which was to determine whether we could use our daily protocol data to extrapolate weight and count of debris diverted. In each of our plots, we saw positive significant relationships between the sebin weight and the count, and the weight of the anthropogenic material in the bin. This will allow us to extrapolate the daily data to mass of anthropogenic material and count of small debris. And this concludes the results show. So we have a few extra slides. This slide represents how we would like to present the data to everyone to showcase the weight of litter diverted in each region and the number of small debris removed. We would like to acknowledge Ports Toronto, who have not only been collaborators, but great supporters throughout this project. We would like to acknowledge Environment and Climate Change Canada and National Geographic Society as supporters for this project. And of course, all of our hardworking volunteers for their help in collecting data this season. If you have any questions about our methodology or the project in general, please feel free to reach out at uoftrashteam@gmail.com and we'd be happy to answer any of your questions. Thanks for listening and enjoy your day.